We now look at the second case of the rational partial fractions. So, and this is the case when the denominator can be factored as again multiple linear factors in which some of them are repeating. So, for example, here I picked an example where in the denominator you can see one of the factor x plus 1 is repeating twice. So how do we make partial fractions of that? So we start with our the expression given and we write it as a over x. X is one of the linear factors and it is not repeating, so it will only appear once in the denominator, plus b over x plus 1. Now we don't see x plus 1 like by itself on the left hand side, but this is how we will do the partial fractions whenever we have the repeating factors. So note here that we have x plus 1 appearing twice, so we put it once and then we put it the square. So b over x plus 1 plus another constant c over x plus 1 whole square. Now if this was a cubed, if instead of 2 this was a cube, then we will have to add another term which will, so there should be as many terms of the repeating factor as the power on the factor. So in this case we have only 2 power or second power of the repeating factor, so we only have to put 2 terms. So next is kind of the same procedure that we did before, that we multiply both sides by the LCM, which in this case will be x into x plus 1 whole squared. So I'm going to put everywhere. Again, now note here this step you may skip because you should be able to see directly, so without looking at this step. So if you multiply the left hand side by this factor, you will see that you only end up getting x plus 2. When you multiply a over x term by this factor, the x and x goes away and you are left with a into x plus 1 whole square, and then plus b into x plus 1, and then plus c into x. So as I said, this you can skip this middle step only if you are expert in doing this algebra in your head. Otherwise you must write this step so that you don't make a mistake here. The next process is, remember, we have to determine these a, b, and c, and to do that we have to now pick values of x which will be helpful. So you notice here that by picking x is equal to 0, and normally you will notice that these are the values we pick are basically the values which are not in the domain of the function. So some of those values which we pick are the ones which are not in the domain. So if you look at the function, x is equal to 0 and x is equal to minus 1 are not in the domain. So when we set x is equal to 0 in this expression or in this equation, we end up getting 2 on the left side equals a times 1 squared or just a, and then the second term has an x, so it becomes 0. The third term has an x, that becomes 0. So we end up getting a is equal to 2. The next one I will pick is x is equal to negative 1, because that is the other term, number which is not in the domain, and then plug in. Left hand side gives us 1. Notice here the expression with the a or the first term on the right hand side will vanish, and the second term in the right hand side will vanish, because putting negative 1 in this factor x plus 1 makes it 0, and we end up getting this third term multiplied by negative 1, so which gives us c is equal to negative 1. So a and c are determined. Now we cannot determine b by a similar method because we do not see a value of x which will make a and c term disappear, or the first and the third term disappear. So now what we do is we will make use of these two terms which we have found, and we pick like any value other than 0 and -1. So the easier one is picking x is equal to 1. So plug in, do your algebra, and you notice that we end up getting 3 is equal to 4a plus 2b plus c. Now plug in the values of a and c that we found, and we end up getting b is equal to -2. So now that we have a, b, and c, we go back and we plug in these values of those coefficients in our those simpler fractions, so that to get the partial fraction. So this is the partial fraction representation of our fraction, and now we can integrate this. So we had, remember, we had this question given that we had to integrate, but now we know that it can be written like above, using the partial fraction. So integration of this will be the integration of each of these terms, and that's what I have here. Now the first term is easy to integrate, so it will give you 2 times ln of absolute value of x. Now this one should be easy, right? You should be able to directly say -2 times ln of absolute value of x. And now if you are having trouble figuring out this or even this, what you can do is go on a side and make substitution, or use any method that you have learned to figure out the answer. Even if you don't do this side work here, directly can give me this answer, it's fine. That should be your answer. So so this is how we will be doing the problems with partial fractions. So note here, just leave the answer in this form. Don't try to combine these two terms using the logarithmic properties. This is your final answer. You will leave it here. Now again, because we used c in here up there, so we shouldn't be putting a c here, so we should have k, or you can say d in this case, but just make it a habit of putting a k, because d is very often used in as a coefficient of partial fractions. Okay, in the next video we will look at the third case.